Space and Science News. With James. In the icy abyss of our solar system, a celestial dance unfolds, defying everything we thought we knew about how worlds are born. Two distant travelers, Pluto and Charon, are locked in an eternal, gravity-bound embrace, their existence a testament to survival against cosmic odds. But this isn't just another tale of distant planets, this is a story of cataclysmic violence, improbable survival, and perhaps even the faint whisper of life in the unlikeliest of places. Imagine a collision so massive, so devastating, it should have obliterated both bodies entirely. A firestorm of shattered rock and frozen ice, scattering debris into the cold void. Yet somehow, from the wreckage of destruction, a new system emerged. Pluto and Charon didn't just survive, they became something extraordinary, a planetary duo unlike any other in the solar system. How did they endure such a cataclysm? What secrets are buried beneath Pluto's frozen surface and Charon's jagged terrain? Could their strange, violent past hold the key to understanding not just their own creation but the formation of countless other worlds in the Kuiper Belt and beyond? The journey ahead isn't just a dive into the unknown, it's a challenge to everything we think we know about the universe. Pluto and Charon's story isn't over yet. And as we dig deeper into their cosmic origins, one thing is certain, the answers may leave us questioning everything. In the distant reaches of our solar system, a celestial waltz plays out between Pluto and its largest moon, Charon. This intricate partnership, forged by a violent collision billions of years ago, offers a captivating glimpse into the chaotic processes that shaped the outer edges of our solar system. Much like the Earth-Moon system, the origin of this dynamic duo is a story of immense impact and transformation, one that has fascinated astronomers and planetary scientists for decades. Charon is not just any moon, it's strikingly large relative to its parent, Pluto. Unlike the smaller moons of Mars or the countless tiny satellites orbiting gas giants, Charon's substantial size has set it apart, making it an object of intense scientific curiosity. Its unusual proportions have spurred questions about how such a unique relationship could have formed. To uncover the truth, researchers have relied on sophisticated models and simulations, which reveal a tale of violent cosmic events and intricate gravitational interactions. Through these advanced techniques, Dr. Adeene Denton, a researcher at the University of Arizona, and her colleagues have constructed a vivid narrative of Pluto and Charon's birth. Their story begins with a massive collision, an event so catastrophic that it not only reshaped Pluto but also gave rise to Charon. This cataclysm likely involved a proto-Pluto colliding with another large body in the Kuiper Belt, resulting in a debris field that eventually coalesced into the moon we now know as Charon. Such a dramatic origin is reminiscent of the giant impact hypothesis that explains the formation of our own moon, adding a layer of familiarity to this distant cosmic tale. But what makes the Pluto-Charon system even more intriguing is the unique dynamic that emerged after their formation. The two bodies are so close in size that they orbit a common center of gravity located outside of Pluto itself, a characteristic that has led scientists to classify them as a binary system rather than a traditional planet-moon pair. This unusual arrangement has significant implications for understanding how celestial bodies interact in the farthest reaches of the solar system. The study of Pluto and Charon provides a window into the processes that shaped not only their own existence but also the broader mechanics of planetary formation. The violent beginnings of this partnership serve as a reminder of the dynamic forces at play in our universe, forces that continue to sculpt and redefine the landscapes of distant worlds. By unraveling their shared history, scientists gain valuable insights into the chaotic and often violent origins of celestial systems, drawing parallels that help illuminate the mysteries of our own planet's formation. The story of Pluto and Charon's formation begins with a cosmic collision of epic proportions. Unlike earlier models that simplified such events by treating the colliding bodies as fluid blobs, Dr. Adeene Denton's research introduces a groundbreaking element: material strength. This innovation offers a more realistic simulation of the impact, revealing a dramatic sequence where Pluto behaves as a rocky core cloaked in an icy mantle. In this refined model, when Proto-Pluto and Proto-Charon collided, their encounter was neither a simple merger nor a violent ricochet. Instead, they engaged in what Dr. Denton describes as a kiss-and-capture scenario. For a brief moment, the two celestial bodies clung to each other, forming a shape that resembled a cosmic snowman. This frozen embrace was far from peaceful. The combined form rotated as a single entity for 10 to 15 hours, with gravitational forces gradually pulling Charon outward. Eventually, the smaller body settled into a stable orbit around Pluto, giving rise to the unique binary system we observe today. This kiss and capture phenomenon stands apart from the more familiar outcomes of cosmic collisions. Most impacts in the solar system fall into two categories: hit and run, where the impactor glances off and continues its journey, or graze and merge, where the colliding bodies fuse into a single, larger object. Pluto and Charon's formation introduced an entirely new paradigm. In this case, the bodies stuck together temporarily but maintained their individual structures, leading to a binary configuration rather than a single, merged entity. The implications of this unique formation process are profound, particularly regarding the composition and structure of both Pluto and Charon. While the collision likely caused some exchange of material between the two, the majority of their original compositions remained intact. Pluto, being the larger body, retained a higher proportion of rock compared to ice, consistent with its rocky core and icy mantle. Charon, on the other hand, emerged with a more balanced composition, approximately 50% rock and 50% ice. This balance reflects the dynamics of their brief yet transformative union, where the gravitational interplay dictated how material was distributed between the two bodies. The effects of this cosmic collision extend beyond their physical compositions. The kiss and capture scenario also explains the distinct orbital relationship between Pluto and Charon. Unlike traditional planet-moon systems where the moon's size is negligible compared to the planet, Charon's substantial size relative to Pluto creates a unique dynamic. The two bodies orbit a shared center of gravity located outside of Pluto itself, cementing their status as a binary system. This unusual relationship has made Pluto and Charon a subject of fascination, offering valuable insights into how complex gravitational interactions shape celestial systems in the far reaches of the solar system. By introducing the concept of material strength into the models, Dr. Denton's work has redefined our understanding of planetary collisions. The story of Pluto and Charon's formation is not just a tale of destruction but also of resilience and transformation. Their unique origin serves as a reminder of the dynamic, sometimes unpredictable forces that sculpt the universe, leaving behind structures that challenge and expand our understanding of planetary science. Through this groundbreaking research, the Pluto-Charon system continues to offer clues about the chaotic processes that govern the evolution of celestial bodies in the outer solar system. The implications of the new formation model for Pluto and Charon extend far beyond the origins of their unique binary system. Among the most intriguing revelations is the possibility that this violent collision and subsequent evolution may explain Pluto's surprisingly active geology and the potential existence of a subsurface ocean, despite its location in the icy, remote outskirts of the solar system. The energy unleashed during the initial collision was immense. Combined with the tidal forces that arose as Pluto and Charon moved apart into stable orbits, this energy could have generated sufficient heat to partially melt Pluto's icy mantle. This melting, in turn, might have allowed the formation of a liquid water ocean beneath Pluto's frozen crust, a feature that may persist even to this day. If such an ocean exists, it could offer a compelling explanation for Pluto's geological activity, such as the presence of vast, smooth plains and the towering ice mountains observed during the New Horizons mission. Moreover, the potential habitability of this hidden ocean opens up fascinating possibilities for life in one of the most unexpected places in the solar system. Beyond Pluto's surface, the formation model sheds light on the origins of its four smaller moons, Nix, Hydra, Kerberos, and Styx. These irregularly shaped satellites likely formed from debris ejected during the collision that birthed Charon. Over time, this material coalesced into the tiny, uneven bodies we observe today. Their very existence supports the kiss and capture scenario, reinforcing the idea that such high-energy events played a pivotal role in shaping the Pluto-Charon system. But the story doesn't end with Pluto. The insights gleaned from this system have far-reaching implications for the Kuiper Belt, the vast region of icy bodies orbiting beyond Neptune. Dr. Adeene Denton highlights that 8 of the 10 largest known Kuiper Belt objects share notable similarities with Pluto and Charon. This suggests that the formation process that created the binary pair may not be unique. Instead, it could represent a common pattern of evolution among the larger objects in this distant region of the solar system. If this formation model applies to other Kuiper Belt objects, it raises intriguing questions about the potential for subsurface oceans and geological activity on other icy worlds. Could some of these objects harbor hidden oceans beneath their frozen exteriors, much like what is hypothesized for Pluto? Are there other Kuiper Belt objects exhibiting surprising geological features that might rival those seen on Pluto during its New Horizons flyby? The possibility of unexpected activity on these distant worlds opens new avenues for exploration and challenges our understanding of the outer solar system. This new perspective invites a broader re-examination of the Kuiper Belt's history and evolution. The idea that violent impacts and subsequent tidal forces may have shaped not only Pluto but also other large bodies in this region suggests a solar system far more dynamic and interconnected than previously thought. The study of Pluto and Charon thus serves as a gateway to deeper questions about the mysteries of the Kuiper Belt, shedding light on the processes that sculpt distant worlds and offering tantalizing hints about the hidden wonders waiting to. The story of Pluto and Charon reveals far more than just the origins of two distant worlds. It's a testament to the incredible complexity and resilience of planetary systems, challenging our most fundamental understanding of cosmic formation. What began as a violent collision billions of years ago transformed into a delicate dance of celestial bodies, preserving ancient structures and potentially harboring hidden oceans in the most unexpected corners of our solar system. This remarkable system offers a window into the broader mysteries of the Kuiper Belt, suggesting that similar formation processes might be more common than we ever imagined. The kiss and capture mechanism opens up entirely new perspectives on how moons and planetary bodies interact, potentially rewriting textbooks and inspiring future generations of planetary scientists. As we reflect on the intricate journey of Pluto and Charon, we're reminded of how much remains unknown about our cosmic neighborhood. Each discovery challenges our previous assumptions, pushing the boundaries of scientific understanding and igniting our collective curiosity about the universe. If you enjoyed diving into the cosmic secrets of Pluto and Charon, don't forget to smash that subscribe button. Hit the notification bell to catch our next deep dive into the mysteries of space. Drop a comment below, we'd love to hear your thoughts on this incredible planetary partnership. Your support helps us continue exploring the most fascinating stories of our universe. Until next time, keep looking up and wondering about the incredible mysteries that surround us. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.